This is the second lesson in this series. So we'll look more at Rutherford's model of the atom. So he originally set out to prove that Thomson's model was correct experimentally. He was a student of Thomson and he worked in his lab, and so he noticed that alpha particles were sometimes deflected by something in the air. So he set up the gold foil experiment, which looks like this. So on the left we have a particle source of alpha particles. Now remember, an alpha particle is simply a helium nucleus. So that's without the electrons. We'll look at that also a little bit later. And then between the particle source and the gold foil, there was a lead collimator, or simply just somewhere where the lead could block off the alpha particles, and then only a stream of alpha particles would pass through. So he fired these alpha particles at a very thin sample of gold foil, expecting that most of them would go through that. And there'd only be a bit of deflection, a slight or small angle of deflection. However, he discovered that these were deflected through large angles, these alpha particles, and some of them even straight back to the source, which was quite a surprise. So to try and picture that, what we need to do is look at the apparatus that he used. It didn't quite look like this. These circular screens were actually being held by research assistants in the lab, and they were flat, but they were held in a circular shape. And it wasn't quite this beautiful. And the gold foil was tiny in comparison to the screens, but nevertheless, this gives us an idea. So the radioactive source, which was polonium, sent out a beam of alpha particles, and most of them traveled straight through the gold foil and hit the screen behind, which was okay, but then there were a few of them that were deflected quite dramatically. And so this is what he expected. Maybe a little bit of deflection on each side, because he thought, as Thomson had suggested, according to the plum pudding model, that the mass was evenly distributed in the atom. And so each of the alpha particles would be slightly deflected or travel just straight through. But he ended up getting quite a bit of deflection in the particles, and as I said, lots of them being deflected back. And so he thought, well, then there must be something wrong with the model. So here at the top, this was what was predicted to have occurred, expected in other words, and then the one on the bottom right is what actually was observed. And you can see some of the deflected particles. What you need to think of is that perhaps this is like a ball of hay or a large bale of hay, and inside of it there are little metal balls, let's say, and these get hit by a bullet, and the bullet could be expected to travel straight through if it doesn't hit a metal ball, but to be deflected in one way or another if it does. So the balls would have to be rather large in comparison to the size of the bullet if they had to be deflected so hugely. And so he visited the Thomson model, and he came up with this model. So if the particles are undeflected, that means most of the gold foil is empty space, right? But if one particle comes along, so that particle came from here and was then deflected up at an angle, well then there must be an area of high concentration of positivity. And similar to this one, which traveled along this, came along this route and hit the nucleus head on and will be deflected at a larger angle. So if it passed close to, the angle was small, and if it hit the nucleus almost head on, well, then the angle of deflection would have been bigger. So in case A, the particle bounces off the atom. Okay, then what do we think? Then there must be a very small, very heavy something that's causing it to do that, and that something is the nucleus. In case B, it goes straight through the atom, so what do we think then? Well, then most of the atom is empty space. If the particle attracts to the atom, what do we think then? And in case D, if the path is altered as it passes through, well, then it must again be a large positive nucleus that will cause the alpha particles to be deflected. So this again, just to reiterate, the plum pudding model was the expectation, and the result, the actual result, was that there was quite a bit of deflection, unexpected. And so we came up with a new model, and this was Rutherford's model. So his conclusions were that the atom was mostly empty space, the nucleus has a positive charge, and that the electrons float around the nucleus. You can write this information down and do the activity. So this is the important stuff. This is what you need to know for the internal assessment. Since most of the particles went through the atom, therefore the atom was mostly empty space. And because only a few of the alpha rays were deflected, that nucleus must be really small and dense. In other words, most of the mass is concentrated in the nucleus. The nucleus must be positive because it was deflecting the positive alpha particles. And the electrons must be very light, since most of the mass of the atom is in the nucleus. And so these electrons must orbit the nucleus in some way.